Today we're going to tell you a little bit about building a global, scalable front-end platform. That's what we do at ING. ING is a huge company, as you know. We work with a lot of front-end developers, and yeah, we're going to give you a little insight on how we work, and hopefully you'll learn. My name is Bob. I'm a tech lead at ING for the front end, and that basically means that I'm doing a lot of software innovation, and I'm leading the My ING project basically. So I don't know if you guys do banking at ING, but the whole My ING website where you log in as a customer, that's the project that I've been leading in the past 3 years. That application is running in the Netherlands, but also in the Belgian market. And yeah, that's myself.
My name is Willem Veelenturf. I'm the lead front-end architect global. We help all the other programs to align. So Bob is one of our consumers. We try to enable them to be very efficient and align globally. So with ING we are present in 40 countries. It's quite a lot. Some are bigger, some are smaller. And we currently run 5 programs to more align on how we do banking. It's not only on IT, but also on the processes, the way of working, the data, and shares. As you see, Unite, E&L is one of the programs. That's really the front side. Next to the 5 big strategic programs, we have a program called Touchpoint. That's the program where I'm working in. And this program aligns all what we offer in the marketplace, where consumers and producers can find each other, so they can share their business services globally.
So about ING's ambition, so we strive to become a global bank. Basically, that we build one application for all of our customers worldwide. Because currently we build in every country a new web application, a new mobile application, and yeah, that's just a waste of time. If you look at companies where we look up to, for instance Netflix or Facebook, you know, the big techs, they don't have different applications in different countries, and we think it's really a waste to do that. Next to that, we strive to be aligned on technology worldwide. That's needed to become one global bank. So that's where we align with DA, with Willem, and all of the other countries to be on the same technology platform. That's the ambition. Of course, next to that, keep building the best customer experience, because we want that 5-star rating, absolutely. So this is way back. The 800 times 600 really does its thing here. It's really nicer now. Yeah, let's not go too deep in it, but this is where we came from. Then we went to web. This is all JSPs, all server-side rendered, also not really front-end technology as we know it today. Then we went to Angular JS. This is already looking a little bit nicer. We did component-based development, so we created little components, and we shared those across applications. We also did unit testing, end-to-end testing. So yeah, this is already sounding more like real front-end development as we know it today. What we also did is that we had APIs and front ends separate. Before it was all linked together, and now we had it separate. And that's way nicer because you can have more clients using the same APIs, for example, mobile phones or watches or whatever. And we still benefit today from that decision. It sounds logical, but yeah, we still benefit from those APIs and we still use them today in the new application.
Yeah, so we were basically looking for our next move. We did AngularJS for 2 to 3 years, and sequel became a bit of old-fashioned. A lot of component-based, more component-based frameworks arise. So React was one of the candidates we looked at. Angular 2, but React still had that weird license where you never sue them when you use the framework, and Angular 2 was basically they changed the interface and the API every month, and it was not a really stable product. So we heard of a project in Australia, ING Direct. They built a full banking experience with web component technology. So that looked very promising. So we all flew to Singapore. Our colleagues from Australia also flew to Singapore. And within 1 week, we could build a whole banking experience with the polymer, the paper elements of Google. So we connected these applications to our transaction API. We were able to log in. So yeah, we were all quite convinced and satisfied about the choice of web components. So we decided to use the platform. So we are not going for a framework, because the frameworks, they come, they go, they have a lifetime of 2 years. Before we were able to transform the whole bank to the next framework, probably the next one already arises. Yeah, we went with the web component standards. And what we do, we basically extend the elements of the browser. We create business functionalities which we can reuse over multiple applications. We can use them in our banking applications, but we also embed them in our native mobile applications.
So who of you is familiar with web components? Who has worked with web components? Not that many people? Okay. So I'm going to tell you a little bit about what web components are. So it consists of multiple standards. I'm not going to talk about all of them, because the most important one is custom elements, we think. And custom elements is like analog to what is a directive in AngularJS in the past days, but also to like React component and Vue.js component. So a custom element looks like this in the browser. It's just like a regular HTML tag, but this one actually has a dash in it, and yeah, that way you can distinguish it, because that's the way you register it. It needs to be a name with a dash in it. So what does this element then do? Well, when you register it, as you can see here on the bottom, this is the way you register it. You register it with the class that's on top of there. And we basically extend the HTML element from the DOM. And when you extend the element, you get a couple of lifecycle hooks that you can call. So there's the constructor, on the stand, I suppose. We have a connected callback. That's the callback that is called when you place your element in the DOM. Then there's the disconnected callback, which is called when you remove it from the DOM, where you can do some garbage collection maybe. And there's an attribute change callback. That is called whenever an attribute changes. You get the values of the attribute, the old value and the new value, and then you can do whatever you want. This is pretty low level, but you can already imagine what you can do with this. You can extend it to whatever you like. And it's actually pretty nice because it's supported in all major browsers. Of course not IE11, it will nothing with IE11, but we will move away from that because over here, you see Edge 75 is coming to us pretty soon. And also it's coming to macOS, also to Windows 7, to all of the platforms. So IE11 is soon this week. So that's really great. And then we have native support for web components in all major browsers, which means superb performance with component-based technology. So if you want to learn more about custom elements or web components in general, below is a link, a good resource from Google. They explain it very well.
Maybe good to add, we can make them work in IE11 with some polymorphism.
Oh, yes.
So it's not that they don't work, but you have to do some extra.
Yeah, we still support IE11. Performance-wise, it's it could be better. That's it. But yeah, it works. It really works.
Yeah, so when we came back from Singapore, we basically started building our web component ecosystem. Our ecosystem consisted of 3 things: a shared library with components, a centralized build pipeline, and a marketplace to share our components globally. So the first thing we started building was a component library. We started out with a material design system from Google, and we took the paper elements, which they created, and we wrapped them and painted them orange. And also we extended that, so from the basic elements, we also created more composed UI components to make a transaction list, or the dialogues, the model boxes, the app skeleton, all these kind of things we offered as one package, which the developers and the programs could use to build their experiences. And we build them all through a centralized build pipeline, because we want to build high quality components. If you share stuff around the globe, people need to know that things are stable and reliable. So in the build pipeline, every project is built, it's tested, it's scanned for quality, and it's published to our internal registry. And it's also published to our web marketplace. And the web marketplace is an overview of all the components we have internally. Currently we have around 1,200 components, and we're growing every day. So people create components, they build them through the build pipeline, and other people can reuse them through the marketplace. Also the marketplace gives insights in quality, gives the documentation. For every component there's a demo. So it's a really convenient way for sharing.
So with all of this in place, we were able to build our first banking application. And it was about 4 years ago, I think. And we're now live for about 3 years. So we had quite a ramp up. It was new technology, so we needed to make it our own, and we needed to really get into it before we really could launch it to our customers. What's also important is that we really started small. So we started with an application that was only consisting of the core functionality that users need. So for instance, showing your transactions, making a transaction, but also feedback, a feedback feature. So you could, as a customer, send your feedback on this new pilot environment of MyING to us as developers. And that basically shows how customer-centric we want to work and how agile we want to work. Because we really looked at this feedback and prioritized which features we wanted to ship based on that customer feedback. We started with one platform team, which was taking care of the whole skeleton and all the plumbing around it, the login, the routing of those things. And then we had 2 feature teams which basically built the business functionality, for instance, like transferring money. We went live for 1,500 customers in the beginning, and that's a very, very tiny amount, but we got some really valuable feedback, and we also saw that people really liked it to be in this pilot environment, and they gave us nice feedback. People like it they feel special basically if they're part of the pilot, so it's pretty cool actually. And then we ramped up, so we gradually rolled out. Still one platform team, but more feature teams, so more and more features, more feature teams, and scale and scale and scale. To basically all customers in the Netherlands. So now we practically have all the features in place, not everything. There are still some links to the old ING in some places, but those are functionalities that are not that often used. So we release by using release train. So one application is consisting of multiple features, which are the dependencies of the application. The application is the thing that goes live. This application goes live twice per week, so that's pretty good, I think. However, we're sometimes struggling with this amount of features on a release train. If something goes wrong, if one team messes up, then the whole train crashes basically. So this is something we are struggling with, and we're looking into actually having teams in complete control of their release cycle. It's nice that the features are already isolated, and we're looking at manners to ship them to our servers and dynamically load them basically. That would be really a great improvement. Do you have a question?
Yeah, you release via monorepo or how?
No, so the features are separate repositories.
Okay.
Yes. What else in the release? So one of the principles that we had from the beginning is that we should be able to run everything we do. I don't know if you have the same thing as your job, but for us it's important that when I do npm install and npm start, it just runs. That makes it very easy to start development. For new people, it's super simple to start working on a feature. So you do an npm-i, you install your dependencies, we do an npm start, and we spin up the mock server. The mock server is a very, very simple Node.js Express server, which just serves some static JSON files from your local file system, and it matches the API endpoint actually. So you can just add your mocks that way. You can configure them to have different responses, so you can mock all the scenarios basically. And that is also then also a web server started, and we proxy all the requests to the mock server. And that way you have a running application on your local machine. Which, it's pretty nice. Also important, like I said, with Angular we already started doing unit tests And of course we continue to do that. But also next to that we started doing accessibility tests. This is something new for us. We didn't do that in the past, but now we capture quite a lot of accessibility errors within our applications. It's quite nice. And of course, we generate governance reports and we publish them to the marketplace. Yes. So there are a couple of things, some area attributes that you should not use on certain elements. Those are the things that you can check. So it's really statically analyzing. It's not covering everything. That's with accessibility impossible to do. You cannot statically analyze everything. You should have a manual check, of course. Things need to be meaningful and labeled. That's not what you do. But that's where we check things. So component types. We thought of three types of components basically that we need for building applications. The first one being the app, and that's like the shell with routing, with the main menus, stuff like that, with the login. Everything is handled there. Also, the security headers and stuff like that is all handled in the application. As a feature developer, you don't need to worry about that. Then, yeah, features. It's showing left hand side which one is what. Yeah, features. An example of a feature is, for instance, doing a payment request, like TEQ. We do that also on the web. It's possible. And features are really isolated, like I said, and they are separate repositories and contain business functionality basically. And they're built up of the UI components. So we here have an amount input, a toggle, another input, some bills, and a button, and selector. So that's how our architecture looked like within our program. And we also had some principles for features which were quite important. So they're isolated. I cannot state it enough. They're also loosely coupled to the application. So they consume data via attributes, and they notify the outerlay application via log events. So this means that you could pick a feature up and put it in our application easily, and that's really powerful. What also is important is that a feature is responsible for its own API calls. So when you spin up a feature in an application, it makes its initial call, fetch some data maybe. But also if you do a post, after when you submit some form, the feature is responsible for that. So we really limit the amount of shared state, because the more coupling you have, the harder it becomes to ship something isolated.
Yeah, the global reuse. So after a year or two, a lot of people started using our components through the marketplace, and programs and applications started to emerge in the marketplace. And because we had all the data in the marketplace, we could do an analysis of the data we gathered, and we were able to generate this network basically. And I will give a little bit explanation of what you will see here. So with the green and the blue dots, which are the applications, so that are the deployable artifacts that are on the URL, accessible internal or external. The gray dots, that are the features, and the small dots are the lead UI components, so the three layers that Bob just mentioned. Something very interesting, what we saw that when we played a bit with the gravity of the graph, that we saw clustering, and we could easily identify the different programs and countries in this graph. So our expectation of reuse by putting everything into a marketplace and people would automatically share and reuse the components, that was not actually true. There were even clusters floating on their own, and which are totally disconnected. The connection between the left, top, and the right is only that they share the authentication component to connect to the gateway. So even the UI components were not shared. The blue dots means that they are not using our core library. They basically started over and built their own ecosystem again. So this was not something that was really in line with our vision becoming one global bank. So we started investigating, okay, what was the cause of why people were not sharing. And we basically found out that there were three reasons. We were not aligned on the visual identity, so applications around the globe look different. In the Netherlands we adopted Material UI, but there were other countries that were thinking that Material UI would not work for their customers. So they started rebuilding their original user visual identity with web components. We had not, also the quality of our initial library was, performance was a thing. So we wrapped all the paper elements, which were not that performant by default, and then we wrapped them again with our orange flavor, and we wrapped them again to make a bigger component, so the performance of the components was not always that good. And we had the architecture, so people talk different about how the architecture is. So the visual identity is, you see it already in this picture, different countries, different UI. So we solved this by making an authority with ING, which is the global UX board. And they decide on the global identity of ING. And they stamp now the components which are reused for global reuse and which not. We also did a big improvement on our shared component library. And we have a cool video which we use internally to promote our component library, which I would like to share. Where's the sound? Where's the sound? Stop.
Did you change your output? Did you change the output of your laptop yet?
Sorry?
Did you change the output for the sound of your laptop yet?
It's connected via HDMI, so it's not connected via HDMI, so the audio should still go through the jack, I suppose.
In your top menu on audio.
Where's our technical? Yes.
We all know the front-end world is changing fast. How can we catch up with the latest tools or frameworks? Nobody can predict the future, but we can be ready for the change. Meet web components. They provide a standard model for the web, and their major benefits are that they can work in any framework. They are flexible, have a good performance, and promote accessibility. We're talking about the latest technology in front end. For example, they use lit element that is a simple base class for creating fast, lightweight web components. Check out some of the ING web components. Accessible and customizable components, ready to use, and with the exact ING design approved by UX globally. Assemble your apps with ING Web. Don't code from scratch. ING Web Components enable one experience for ING worldwide. It increases flexibility, reusability, and scalability, and simplifies how we roll out ING global solutions. Are you ready for the change?
video of our web component library. So people really like it. So it's the latest technology, it's web components, it's fast, it's flexible. We put a lot of effort in accessibility, which is still a thing that's not a web component. So that really helped in improving the collaboration globally. And also what we did, we aligned better on the up architecture. So we extended basically the up architecture that was using Unite, and we improved that. But we did not create it, but we did it as a kind of group exercise. So we brought all the programs together, and together we decided on what is the layered architecture we are going to use. So to get a kind of shared vocabulary, which was the hardest thing because we were not able to agree on names. So we ended up with layers and numbers and then responsibilities, and that's what we ended up with. Later on, names are attached, but yeah, names are always hard in IT. We learned that that day. So yeah, we have the layer 5, which are the atoms. They are inside ING Web, basically the core, the UI fundamentals, and some systems for translation, for fetching, for all the things to connect to the ING network. Layer 4, that are the molecules. They are more composed UI components, but they are not connected to a backend. You can think of a authentication form and transaction list, but only accepts an object with data and doesn't do any API calls, which you can reuse to build your layer trees, which are the widgets or features, we call them now. These are connected components, so they are responsible for their own API calls, but they are still isolated, so they are not allowed to interact with the application around them. Then we came with the integration layer, which is hard to visualize because it's basically the glue that sticks all the features together in the application. Sometimes you have shared states. You don't want to fetch always the user that is logged in or the transactions which are maybe available in the platform. So some of the data will be connected to the features to optimize the amount of calls that the features make. Also the router is something that you have to share sometimes if you want to deep link into a feature. You need some information from the router that needs to be passed down to the feature. And then the layer 1 is the application itself. This is the deployable artifact that goes to our frontend servers and gets attached to a URL so people can actually visit it. So it was very funny because 6 months later we created the same picture, and then ING Web was released, and we already saw that orange dot there in the middle, and basically the two programs were more connected. We even strive for more connections. So in the next slide. This would be our ideal picture, that we have one connected front-end platform where all features and applications are shared and reused appropriately.
Yeah, so in the meantime, we in the Netherlands got a request. We had our application, it was live for many customers, and it was quite successful. So at some point in time, Belgium came along and they said, basically, we want to use the same banking application for our customers. So we sat down and thought, okay, what would that actually mean? Because they also wanted to gradually roll out. Maybe some data was not migrated, some APIs were maybe not available, or some products were not available in the Belgian landscape. So we really thought about it, what it would mean. And I'm going to show you the application and show you what types of things we needed to basically configure, change in the Belgian website. So if you So one of the examples is that, very visual example, is that over here we have our language change options, and it's only showing us 2 languages, Dutch and English, but of course we need to have Flemish in there as well, and also French in there as well. So this is one of the changes we need to make. Also one of the changes was that in the previous, I can show you. So in this application over here, we have a link to all my ING because some functionality is not available in this new environment, so we needed to link customers being able to link back to the old application. But of course, for a Belgian customer, going to my.ing.nl doesn't make any sense. So this is a navigation option, a link that we also need to be able to configure. And next to that, we had some other links to legacy systems, or maybe Belgian legacy systems that we basically needed to configure. Also, in some features, maybe in Belgium or Netherlands, one field maybe would not be applicable. One field maybe needs to be removed in the Belgian version of some features. So those were the things we needed to change. So we inventorized that and figured out that we need. I'm going to show the presentation again. We need some kind of configuration, and we first thought, yeah, let's do this build time. Then it's very performant and will be easy to implement. But then again, it would not be very flexible because one build is just very static. We want it to be really dynamic actually. So we came up with an API basically. This API contains the application configuration, as we call it. So this API is initially called when the application gets rendered. And yeah, then we get the configuration based on the user's country. And it's just a JSON file that passes the right properties to the right components. So one of the examples over here is for links and navigation. So we have site navigation. It shows, it's basically a link. Everything is a link. And in the Netherlands it goes to the overview, but and it shows a wallet and there's a transaction key. And in the Belgian version of this component, for instance, the products link would not go to the products link as we do it in the Netherlands, but it would go to mying.be/products, for instance. And also you can see here that one of the options is removed, and that's by just removing it from the configuration object from the database. That way, our application becomes very flexible, very configurable. And that's super powerful. And one of the things that we also need to do is, like I said, showing and hiding things in the feature. So if, for instance, you have the payment request and there's a little toggle there, but we would not want to show that in Belgium. And how would we go about that? I don't want the feature to know about Netherlands or Belgium or those kinds of things. I just want to have a meaningful setting for that feature to toggle it based on the configuration that comes from this API. So this is the way we do that. In the application, we fetch initially the application configuration, and somewhere in this integration layer, we fetch the specific property that we need to pass down to the feature to have it changed by a meaningful thing and not like this. Check if someone comes from the Netherlands, someone comes from Belgium. That's definitely not what we want because this is not scalable at all.
Yeah, so what did we learn in the last 4 years? We learned that we should use the platform to do component-based development. We have created a platform ecosystem to be able to share components globally. Yeah, we needed to align on the UX, the app architecture, to be able to be scalable. Yeah, and our next move is how are we going to configure applications so we can reuse applications over countries and programs. So our ambition is basically to build this. This is the International Space Station. And it's also assembled of a lot of components which are built by different countries. Our vision is to build a platform where people around the globe can build features which can be assembled into one application that serves all the customers of ING. Thanks.
Thanks very much.
Hi, I have a question. So you share components, and I was wondering how do you manage changes in these shared components?
Yeah, that's a good question. So we have shared dependencies, obviously. Those the core UI elements are shared across all the features. These are in one runtime with all the features having shared dependencies. So with the release train, it is indeed challenging to coordinate breaking changes in our core UI libraries. This is challenging, but we really found a way, and that basically is the core UI or the shared dependencies need to be predictable. They need to be really strict semantic version, in order to be predictable. And they only now change major versions once per quarter. That's what we ask from them because we cannot handle anymore. And it's really doable. It really is. So by that way, we still manage to go production 2 times a week. And yeah, the breaking changes, they need to be coordinated, but that's, it's unlevable.
Just a couple of times per year.
Only a couple of times.
4 times a year. That's also one thing we learned. We started out with every component separate dependency to the features. Now we group that into one dependency, so every feature has one dependency on the collection, basically, which is one version, and yeah, we don't change it too often, 4 times a year max. Although changing the core library is a painful exercise to get it.
And then all the teams need test their.
If it's breaking, we have to.
Because you can do a lot of stuff automatically, but yeah, you need to verify. Okay. Let's go there.
How do you promote the reuse? Because when developers don't know the existence of certain components, how do they know of all those components?
So the marketplace is one thing. But yeah, if you see the marketplace, 1,200 components, you type it and you find 5. What is the one that is best to use? So that's why we have the scoring, so the quality of the components. But in the new version, we are going to introduce a kind of stamp where we stamp them. These are the preferred components, like the card, but the basic components, we are going to identify them as the preferred components to use.
How is that quality determined? What determines the quality of
And there are multiple factors. You have a couple of libraries, of course, for instance, code coverage. We also have libraries to get the complexity of the code. Those kinds of factors all weigh in. Also, do you have a demo? Do you have README? Do you have your documentation in place? Those are all things that add up to the eventual score.
Also, an interesting measure is the reuse. So if a component is already used by a lot of other applications or features, then yeah, it's a popular component. So that also helps deciding what to use. The same in GitHub. You're not going to use a project with 1 star. You always look for the project that has more stars.
Yes, go ahead.
Do you use JavaScript or TypeScript for the components?
We use TypeScript for libraries because it's handy for libraries because of the interfaces that you have with libraries. But for components themselves, it's all JavaScript, and that's because everyone knows JavaScript, not everyone knows TypeScript. You can choose for yourself as a team, but yeah, think about the consequences basically. What does it mean when a new person starts in your team, a new front-end developer starts in your team? She doesn't know Daarnaast TypeScript, it doesn't really like TypeScript. I mean, the web is still JavaScript, so start out with JavaScript and you could choose it.
What about the backend APIs? Like, do you have interface definitions in TypeScript that they can use, or is it just?
No, we don't have that.
Okay, so it's inspector network tab and see what you get back.
I'm sorry?
Is it documented, like the
APIs?
Yes.
Yes, of course. Yeah, Swagger and opening UI, that kind of stuff.
But no autocomplete in your IDE.
No.
Would be a nice feature to introduce. I think there TypeScript makes a lot of sense, where you have complex interfaces and you can really make a definition of the. What Bob said, we started out with the libraries in TypeScript, but we also got feedback like, yeah, how can I make a change or how can I test something? Because you always have that compile step in JavaScript. You can even manipulate the code in the browser and see if it works. And this step is also something that the developers not always like.
And you could, of course, use still the TypeScript compiler for your JavaScript, and you still get a lot of benefits from TypeScript compiler. So that's wonderful. Yes.
So all these different configurations, how do you manage them and where do you manage them?
That's a big challenge. So currently it's very simple, just an LBE, 2 JSON files. But we are planning to extend it to make it more smart, also more flexible, more personalized, maybe even in the future. And that's something we need to have architects with us to figure out how to work. Because now it's a very simple thing, but it works great. Yeah, let's take a look at we will solve that. I'm not sure. Good.
One more?
You talked a little bit about accessibility testing.
Yes.
Can you explain to me what that is? Because I haven't heard it before.
So do you know Axe? AXE. It's a Chrome plugin. You should download it, and it runs in your browser. You check your HTML for accessibility errors. That one you can also run in the pipeline, for instance, and get a report out of that. And by that manner, have accessibility issues found in your code base. And this is a really good tool. I can really advertise it. It's really a nice tool. AXE. Alright, I think that was it for the questions. One important thing to notice, if you are looking for a cool new job, we at ING do awesome stuff, so we have a booth below. You're welcome to visit us. And thanks for listening.